Hello, can you hear me? Okay, is it better now? Perfect. So I'm very happy to be with you today. And to introduce you to Musimap, which is a cognitive music intelligence technology based in Belgium. What we are doing is to bring the personalized music recommendation to an unprecedented level and to allow developers and companies to access our granular database through our APIs to challenge the user experience and the application that could be made so that people can enjoy music differently. The problem we are facing or we are trying to address or to solve is the following. If you look at Klaas Briller, is the producer of Jazzanova. He is known as an archaeologist of music. He has a huge discotheque and he hardly finds his way through this huge quantity of tracks according to his personality, his taste, his emotion, his moods. The question is, how would Klaas deal with 50 million tracks? Because music is the first digitized industry, so we have to have a closer look at that. To meet this challenge, we have gathered a great team with Pierre Lebec working on this subject since '86, but we also brought a lot of interdisciplinary people on board from different segments. So, for example, you have Daniel Levitin here, who is a neuroscientist. You have linguists, you have sociologists, you have psychologists, you have philosophers, you have IT specialists, text retrieval specialists, and so on. So it's 60 contributors, 20 years of research. You might recognize here Gilles Peterson, Carlos Bartos from Kraftwerk, or Levitin in the middle. With this great team, we tried to interlace data points of what would be a huge, the biggest database in the world about music and its content. So we gathered, or we integrate a lot of layers, different technological layers to do so. And I would say as the strength or the differentiating factor that we brought here is to bring soft criteria back into the game, back into music recommendation. We believe that music is about emotions, influence, relation, and if we don't take these parameters into account, then you miss the boat and you don't make a good recommendation. So it's soft criteria on top of traditional signal analysis and text retrieval. Our algorithm is basically applying 55 weighted parameters to each music unit so as to model the world's discography as a multi-layered system of cross-influence. In other words, what we try to achieve is a first emotion-sensitive cross-weighted music taxonomy, which is a very complex underlying map of the world's music history and influences between artists, tracks, genres, albums, and so on. So if we take, for example, a track, let's take Feeling Good from Nina Simone, we try to understand, the track is in gray there, we try to understand how it relates to the album, how it relates to the artist itself, to the genre, and we add layers of semantic, of our own lexicology to describe, we use describer of emotional state so that we can go deep into music and decode the music's DNA. There I wanted to offer you this music genre flower today. These are the families, the genre, subgenres, and we go up to 1,500 subgenres to describe music in its whole complexity. When I'm speaking about our database, we have put a lot of efforts to grow it to the current state, and we have up to 2 billion data points, 750 million relations, 50 million tracks, 4 million artists, and we are using 11 keywords, lexicology of 11 keywords to describe music. We are classifying music in 400 genres and 100 contexts, so that we can take into account everything that we think might be useful. So it's constantly growing. We are now at 200 million nodes, and we won't stop. So basically, we have this data. We try to gather all data, metadata about music in the world. We analyze them, we translate them, we filter them, we reinterpret them in our own lexicology. We put extra layers of data, notably this emotional parameters. And with this, we have 4 APIs that allow companies and developers and people to create new user experience and interfaces. We are basing our work on Neo4j and also speeding the process with Elasticsearch so that any query you might do is taking 0.2 seconds to bring you this answer you are craving for. So it's basically one algorithm turning to 50 million tracks and bringing you an answer relevance with a great relevance in a fraction of a second. What I wanted to show you today, as our APIs are just ready, is a first interface that we have created for audiovisual professionals to help them find the right tracks for their projects. So I want to go into it now to show you one of the many possibilities that we have with this technology. So we have, that's the dashboard that you have. You can make any search in natural language and search for any track, any mood. And you can then specify your search. For example, you would go in styles and you would define the styles you want to go to be, do you want the track to be off? And you define a level of influence from this style. And then you can add other styles and make your own mix of genres in this manner. So that's the first way you can search. Then you can go in moods, because moods and complex moods are very difficult to tackle. So psychologists and sociologists worked a lot on that to define 18 families of moods and to add specific words to create 400 complex moods that you can search with. So for example, we can go in coldness and we have all the related words. You can define the level of the percentage you want this mood to be taken into account, and then you can put dynamic, for example, and once again put another layer on it, and you can go on and on with this to have the best results on your search. So every result is on the bar below with a relevancy level, so that you can listen to the tracks and get the right music according to what you are searching for. Then if you want to go more in detail, you can define if you want an instrumental or a vocalist on it. You can define the rhythmic signature. You can play with the BPM, define the years the track has been released, the duration of the track, which is very useful for music supervisors, for example. And you can go deeper into many parameters. For example, subgenres. We have 1,500 subgenres there. We have 11,000 keywords to search for things that are very specific. And then you can enter special facts such as mashup, cover, if it's a live track, or whatever it might be. Then you can go into instrumentation. So if you want 12 instrumentalists, you want to define exactly which instrument they should play, then you will get results that exactly fits your dream combo, and that's what this machine allows you to do. Then you have the main keys. You can define if you are in which tonality you are, for example, here. And you have also the type of voice, if it's male, female, if it's not defined, what you want to have. Is it a broken medium male voice? Is it a female voice, sensitive one? What type of voice do you want? You apply all of these criteria, and you can always see them back on the summary and continue to fine-tune your search, your query on the dashboard. Finally, you go into situations. So that's the context you are in. So if you are at a romantic dinner or doing bass jump in the mountain, it's not exactly the same thing. So you might be able to specify that, and you can choose your rhythmic moods, the rhythmic signature, and the language of the lyrics, and search also for keywords in the lyrics. So that was one example of a specific tool that we could achieve to help audiovisual professionals to find their way in music. And our objective now is to allow 50 developers here at MusicTechFest to search and challenge our technology to come up with great ideas, and we are very excited to see what could come out of it. Thanks a lot for your attention.